All right, so welcome to the review for tests for Unit 3 on slope-intercept form. All right, we started with basic points. All right, now but we also started with the quadrants. Make sure you know where the four quadrants, 1 through 4. So Roman numeral 1 is there, and then it goes counterclockwise, the opposite of a clock. So that's quadrant 2, quadrant 3, and ID is 4. All right, so we're going to plot some points. A is at 1, 4. B over there is at -8, +5. C is at -2, -7. D is at 3, -3. E is at 0, 8, right? You have to get the 0 first. F is at -5, 0. G, it's not where the letter is, it's where the point is. G is at 0, 0, and H is at 9, 0. Okay, now, let's just, before I answer what's the domain here, let's look at where these points are, right? So A is in quadrant 1, right? Where both coordinates are positive. C is in quadrant 3, where both coordinates are negative, right? This is in 3. And that's in 1, all right? B there is in quadrant 2, right? D there is in quadrant 4, right? And B starts with negative and then ends with a positive, and quadrant 4 starts with a positive and ends with a negative. E is on the y-axis, right? Because it starts with a 0. F is on the x-axis, and so is H. They're both on the x-axis. And 0, 0 is on both axes, and that's the weird plural of axis. Now, what's the domain? The domain's not all real numbers here. This is not a linear function. The domain is all the values of x. So what are all the values of x? 1, -8, -2, +3, 0. We don't write anything twice, -5, and 9. The range would all be all the y values, because this is just a bunch of points. Right. So we first learned how to plot linear functions the slow way, and using a t-table is the slow way. So y equals -2x + 3. So you put, we have to know the vocabulary. This is input, that is output. So you put x in, and you get -2 times 0 + 3 is 3. And then you plot that point. And then you put 1 in there. Now you can do this in your head and put 1 in there, and you get 1. And then you put 2 in there, and you get -1. And you get 3 in there, and what do you get? -3. And you put 4 in there, you get -5. All right, and then you take your ruler, your straight edge, that you're going to be using for the next several weeks, and you draw your line. And that's the slow way, okay? All right, so let's now remind ourselves what the fast way was. The fast way would be to start at 0, 3, right at the y-intercept. Instead of doing all this math, you would go down 2 and over 1. So it says, show the slope of the triangle between 2 points. Well, that's what I just did, and the y-intercept on the graph. Right, but it's down 2 and over 1 for a -2 slope every time. Right, how do you check whether a point's on a line? Well, you put it in, right? So this is an x-coordinate and a y-coordinate. And so the y-coordinate is -14, the x-coordinate is 5. You do the math, and -20 + 6 is -14. So, yes, that is on the line. Has to be. How many possible ordered pairs are on that line? There's an infinite amount of points on every line, okay? And what are the domain and range of the function? All right, so now this is a linear function, and it's a linear function, right, that looks like that. It's not horizontal or vertical. And so when it's not horizontal or vertical, the domain and the range, both of them, so I don't have to write it twice, is all real numbers. This goes on forever in both directions. That's why the arrows are there. All right, so we're going to find the slope of all of these. All right, so we started in the first quadrant. All right, so if you're going to make, you can make 3 different sketches if you prefer, but this one, right, has a rise of 4 and a run of 1. And you could do it here or there, right? Here or there, and you would get a slope of 4. And no leaving it 4 over 1. Simplify your fraction, right? The horizontal one here, right, has a rise of 0, and it doesn't matter what you make the run, it has a slope of 0. Horizontal, and you have to know that's a horizontal ray. Okay, last but not least, the only one that is at least a bit tricky here is this one. All right, so there's the good intersection, there's another good intersection in there, so I'm going to do it here so we avoid the mess. So this is down 3 over 2, so the slope here is negative 3/2. Right, and these are rays because they don't have arrows on both ends, they have arrow on one end. All right, so what's the slope? 7. What's the y-intercept? 0, 2. Easy peasy. Right, the coefficient will be the slope, the coefficient of x. The y-intercept here is 0, 0. Please, if you write 0 is the y-intercept, wrong. If you write 2 is the y-intercept is a point. Slope is a ratio. All right, and again, this is the tricky version to know. Do you know that the slope there is always the coefficient? So the y-intercept here is 0, negative 5. Now you're going to work backwards. And you are not going to leave it that way. You're going to make 1x x and write y equals x minus 3. You're going to be typing in linear functions. Here, the slope is 0. The y-intercept is 0, negative 8. So write this 0 times x. 0 times every number. 0 times a million is 0. This goes away. And this is a horizontal line, right, that looks like this, where the y-intercept is 0, negative 8, and it looks like that. So you're given this graph. I gave you the good intersections. And so the slope is 2/5. The y-intercept is 0, 5. And it's y equals 2/5 x plus 5. This one down here, notice the difference. This is where the mistakes will happen, right? People will say this one has a slope of 2/5, but it doesn't. It has a slope of negative 2/5. And its y-intercept here is what? Negative 6. Right, so these lines are parallel. You have to know that parallel lines always have the same slope. So you know they're parallel when you verify that. All right, so this rise is 1, 2, 3, 4, 5, and the run is 2. So they both, it looks like 1, 2, 3, 4, 5. Yeah, they both have a slope of 5/2. One of them, has a y-intercept of 0, 1, and the other one, I guess, has let's use a different color. Has a y-intercept of 0, 8, right? And so this bottom one is y equal, please don't forget the y equals, or it's wrong. Y equals 5 halves x plus 5. I should be neater about that. Make sure the x is in the middle or higher. And the one that's parallel to it is y equals 5/2 x plus 1, right? Parallel lines have the same slope, just different y-intercepts. All right, so we have to draw or write another linear function that is parallel to it. So you have to use the same exact slope, right? And then you have to use this y-intercept. And I drew that one here. There it is, the y-intercept. Right, those are all parallel. So, right, when you're given 2 points, you subtract the y coordinates, y sub 2 minus y sub 1, we say, over x coordinates, x sub 2 minus x sub 1. Doesn't matter which one is first, as long as you're consistent. You start with 9, you got to start with 5. 9 minus 7 is 2, 5 minus 1 is 4. You have to simplify slope is 1/2. Okay, so now we're going to find the linear function that passes through these 2 points. So we need to find the slope. So we'll do -3 minus 5 over -6 minus -4. -3 minus 5 is -8. -6 minus -4 is -2. So the slope here is 4. Right? Are either of these points the y-intercept? No, they are not. So we're going to put y equals 4x plus b, right? We're going to try to find b for the y-intercept. So we can use either point. I'll use that one. So 5 equals 4 times -4, x coordinate is -4 plus b. So that's -16. So we add 16 to both sides. Looks like b is 21, so the y-intercept is 0, 21. And so it's y equals 4x plus 21. Yeah, I'm not graphing it, so I can have y-intercepts of anything. All right, so this is a non-T table, a regular. This is called an input-output table. And the key with this is that, when you do slope, y has to be up top. So I'll do this one, 2 minus 1. Over 4 minus 3, right? X is on, right? When we're doing slope, y is on top. The graph is upside down from the way you need it. All right? The slope here is 1, though. All right? The y-intercept, we could do what we just did, but it's there, right? Where x is 0, y-intercept, then if x is 0, that's the y-intercept. So it's y equals x minus 2. Let's just double check that, right? So you take the x and subtract 2. Do you get the other one? 1 minus 2 is -1. 2 minus 2 is 0, right? 3 minus 2 is 1. 4 minus 2 is 2. Yes, that makes all these combinations. Same thing here. So we're going to find the slope. Let's do -9 minus -3 over 7 minus 5. -9 minus 3 is the same as -9 plus 3. -6 over 7 minus 5 is 2. The slope here is -3. Is there a y-intercept? No, too bad. I got to do work. Okay, so we're going to put one of these points in there. Let's pick this one just to be different. -15 equals -3 times 9 plus b. So that's -27, right? So we're going to add 27 to both sides, which 12 equals b. And you could have picked any point. You'll get the same answer. Y equals -3x plus 12, right? The y-intercept. I didn't ask you what the y-intercept is. I just said find the linear function. So that's all you needed to write. All right, so now you're going to plot this using the slope and y-intercept. So the y-intercept is 0, -6. Right, and the slope is 1/2. So what is 1/2? And if you're nervous about this, you go right. You draw yourself a little chart. All right, so 1/2 is over 2 and up 1, right? So over 2, up 1. And so then once you've done that, it looks like that. So let's do this one on the same graph. All right, so the y-intercept is still 0, -6, same exact y-intercept, but this is a slope of 2, and then I'm comparing these two, over 1 and up 2, right? That looks like that, so over 1, up 2. Right? Make sure you have the difference between a slope of 2 and a slope of 1/2 straight in your head before you start the test. And so that one looks like that. And again, if you're unsure, you could do it the slow way by plotting the points, right? X is 0, 2, and you go x is 2, and so on. Right? X is 2, and y is -2 is right there, and so on. All right, so horizontal and vertical. You get those backwards on the test, you're in trouble. All right, so find the slope of the horizontal line. All right, so you have to know that's the horizontal line, and the slope of every horizontal line is 0. And then you're going to write a linear function for that, right? So it's y equals 0x. The y-intercept is 0, 4. So it's y equal -4. So it's y equals -4. My fault. And so the linear function, and that is a linear function. That is a function. And it's y equals -4. Okay? And that is in slope-intercept form. It's just that the slope is 0. Okay, now the vertical line. The vertical line is not a function. That's why it says write an equation. It doesn't say write a function like it normally does. That's a dead giveaway. You're about to do a vertical line. Right? The slope here is what? Is undefined. You need to know that for the test. The y-intercept, there is no y-intercept. So none of the stuff we've been doing works. So what do? Well, x is 6 everywhere along this line. And so the graph here is x equals 6. That's the equation that makes that line, right? Y is -8, x is 6. Y is +7, x is 6. It's every point on the line. Plot the graph of y equals 5, all right? So that means it's a horizontal line where the y coordinate is always 5. Okay, oops, I missed, so let me fix that. And still not that great. But all right, so the domain here, what are the possible values of x? X could be anything, right? It goes on forever, so that's all real numbers. But here's the only time, right, vertical and horizontal, the only time when these are not all real numbers. The range here is just the number 5, right? Y can't be anything other than 5. It says that right here, y equals 5. All right, and then this one, x equals -7 is a vertical line. Goes like that. And so what is the domain and range of that? The domain here, x can only be -7. And then the range is now the one that's any possible number, or we say all real numbers. All right, good luck on the test. Do not take it until you are ready.